Alrighty, folks, and we are back. We have just a little bit left to finish up here. Thunderstorms and rainbows. So, we mentioned several times in the previous conversation the complexities that need to happen with a thunderstorm. The fact that they're vertically monstrous things, and when you can see these things off on the horizon, really that's the only time I truly get an appreciation for the different levels, the different altitudes of clouds that are supposedly out there in the world, because this one looks like it spans them all, from the low bottom of cumulus clouds through the steam pipe up to the anvil head. And like I said, it's so rare that you see that full shape. Really, really cool when you actually do. And because of this immense height, you get a temperature difference. The lower stuff, you're definitely working with water droplets, and in the top parts, you're working with ice crystals. And that together, along with the insinuations I made the other day of energy transfer and energy tied up in all these phase changes, it leads to this rather awesome event of a thunderstorm. There's another picture. So when they say anvil shape, that's what they're talking about. And there's lots and lots and lots of articles and discussions out there about what exactly is going on, and it really is one of the places where they're still learning, in all honesty. So when we think of a thunderstorm, we think of a handful of things. Heavy rains, thunder and lightning, obviously. Maybe strong winds, and the hail that we mentioned the other day. We talked about how the hail formed already. The heavy rains, of course, come from the huge, huge cloud droplets that have formed, and just the immense size of the cloud in itself, in and of itself.
You said something about a barometer last class, right?
Yeah.
When I was working at my client's house, there was one and I never saw one before.
You've probably passed 1,000 of them and never knew a barometer until I. Was it the old-fashioned one where it says fair to good to excellent, or what was it?
Hers was like, it was cute. It was like rainy, chilly, warm, but it was in like cute fonts. It was so cute.
Elderly lady?
Yeah, she's
like
a client.
Yeah, it was the generation before we had access to all this crap on our phones. Would have those.
Thermometer, barometer.
Yeah. There was a trio set too. One of them would do probably just redundantly doing humidity, because your barometer is kind of mirroring humidity. But yeah, you'd see the trio there. The temperature, humidity, and then barometric pressure was often the set to have. And they had fancy brass ones in wood cases, and they'd sit on the old stereos that were as big as these tables. And yeah, those were the days, my friends. So now we need to talk about lightning and thunder formation, because we hit most of the others. Lightning's cool. Lightning's awesome. Lightning's scary as hell. Anybody here ever been hit by lightning? Good. Know anyone that has, or been near a tree or something?
Yes.
Yeah. Which
in the aftermath?
One of my old coworkers, his car got struck by lightning while he was driving.
Wow. What if anything happened?
He had to learn how to walk his whole left side.
What got him?
Yeah.
They say you're supposed to be because of the rubber tires. He must have been touching something. Because of the rubber tires, you should be grounded, I thought. Maybe he was touching something metal. Good Lord. He's all right, though, in the long run? Good.
Something similar like that happened
somehow the building that he was in like got struck, and he was touching something metal that wound up hitting him too.
Yeah.
And he had to go through like that same process, like learn to walk again. I know he was hospitalized for a while. So.
My great grandmother, would not let us play the upright piano for fear that lightning would strike the piano inside the house. It wasn't electric. It was just a standard piano.
That's a different one.
Yeah. She was a little nervous wreck.
We were not allowed to talk on the telephone. That was a big thing when it was thunder and lightning out. Apparently somebody somewhere once got electrified through the phone lines. I don't know if that was a Mythbuster, should have hit that one. But yeah, and there's that park ranger out. I don't know if it was Yellowstone. One of them out there. Guy got hit 6 times, and he just kept on. Yeah, he'd go back and do his job again. He was like 90 something when he retired. So it's there. It's complicated as well. The neat thing, and you won't believe me, but the neat thing is that lightning actually goes from the ground up. You don't see it that way, all right? But it does go from the ground up. The charge of the earth attempts to reach the charge in the cloud. So the ground is positively charged, the storm is negatively charged. 2 charges grow closer and closer together until they touch. The energy is transferred. Lightning travels from the ground to the cloud. All right, and I've got a little video that hopefully will run where you could maybe almost kind of see it happening. Apparently it's not yet, though. So this has a lot of print in it. It's not the best, but it does a good job of explaining all of the different options here. You've seen cloud-to-cloud lightning, perhaps. That's neat stuff, too. Again, as long as you get your positives and your negatives next to one another, it will transfer. And this shows how that could happen. And then, of course, again, the ground being positive, the clouds negative. I got a good one for you guys. What is heat lightning? What is heat lightning?
Lightning that has no thunder to it.
Lightning that has no thunder to it. All right. Anybody else?
What is what lightning?
Heat lightning.
Heat lightning?
Yeah. You should work on this class when we're in this class. Please. What is heat lightning? Okay. That's a thing people talk about. It's not a thing. That's the thing. But everyone talks about heat lightning. It's on a summer night, and you see the lightning, but you don't, as she said, hear the thunder. You don't have rain. That is a storm that is way, 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 way far off. All right? And the sound waves don't travel as good as the light waves. So what you get is the thunder kind of dissipates out into the world. And we've still got the lightning making its way through. I think we have a slide about that one too, but yeah, it's at the bottom of this one. 60,000 meters per second, which is 220,000 kilometers per hour. Speed of light is pretty fast. Temperatures, 30,000 degrees Celsius. I put it in Fahrenheit for you, not that 54,000 Fahrenheit's any easier to fathom, but and again, heat lightning, heat lightning is still a storm. You can't get lightning just from heat. And typically, the reason is because it's hot where you guys are and humid where you guys are. You just haven't had the right conditions for a storm yet. Some folks know the 1.21 gigawatts from Back to the Future. That is a thing. All right, it's 1 billion watts. It's another way to think about the lightning. That is enough to power 10 million 100-watt light bulbs. All right, if only we could harness the power of lightning and keep it. That would be some awesome power generating. All right, so here's the little video that in theory shows, if you cycle it right, shows it returning back up to the sky from the ground. You see the really faint stuff at the bottom, and where it meets, I'm guessing where you finally see the light is where it's meeting the negatives down from the cloud, and then you can see that it does actually go up. If you kind of think about it backwards. It's like one of those pictures where they ask you if you're seeing the old woman, the two faces or the candle, or the old woman or the young woman thing. Once you see it one way, it's kind of hard to unsee it and see it the other way, but hopefully you can pull that out there. Now, you really can't have lightning without thunder. You just can't hear it. Thunder is because of the lightning. And what happens is that lightning heats up the air so gosh darn fast that it expands. Remember, we've been talking about air molecules expanding and contracting due to temperature, so on and so forth, right? So these air pockets that are in the area where the lightning is, you're basically seeing a sonic boom of the air. All right? And that's what thunder is. The rumbling nature of it comes from it, the sound waves bouncing off of other objects out there. And there's a great way to prove that. You can't really orchestrate it yourself, but if you've ever been in that situation where the lightning cracks very close to you, there's no rumble. It's just boom, and it's boom. The lag between the lightning and the thunder is a cool thing. I think I have a slide for that one coming up. You can time a storm. I would never use it in a life or death situation. You count between when you see the lightning strike to when you hear the thunder.
There's a great children's book about it, Thunder Cake.
I don't know that one. I remember from Poltergeist. Scared the hell out of me as a kid, but that was the only useful thing I got out of it. Thunder Cake. That's a good one. Did they use it to calm the kid down that the storm was leaving?
Basically, yeah, they timed it so that the kid remained busy in between the lightning and the thunder, and they counted, and you got your ingredients, and then you broke it down.
Oh, it's a cake? They literally make
a cake.
Interesting. So I wouldn't use it, in super, super important situations, but it is a great way to tell if a storm is leaving or coming still. If the thunder and lightning get closer together, then the storm is still approaching you. If the thunder and lightning get farther and farther apart, then the storm is leaving you. And again, that's pinnacled with when the lightning and the thunder are instantaneous, when it's right on top of you. So we said that. So yeah, here's the big difference. 186,000 miles per second versus 0.2 miles per second. All right? Huge difference between light and sound. And this is that 5 second. This is the set I wouldn't trust your life on this one. But there are some crazy storm hunters out there in the world, and maybe you're one of them. But they say there's a 5 second lag per mile. So. All right, rainbows. There was a poster when I was a kid of, nobody knows who Ziggy is anymore, but this simple little round guy with some legs. Bunch of little guys that look like Ziggy, kind of like the pizza guy for Little Caesars. All right, just simple little people. And they were all in painter's hats and whatnot, and they were painting a rainbow. All right, and that was a nice, real 70s, sunshiny, happy day kind of way of thinking about a rainbow, and that's, of course, how I grew up seeing. This, in reality, rainbows are amazing amounts of geometry. Nobody sees the same rainbow. That's very true. All four of you could line up at the window here, and you would see, all five of you would line up at the window here, and you'd see 5 different rainbows. You could line up in a straight vertical line, and instead of one per window, and you'd see 5 different rainbows still. It's all about the interaction of your eyeball and the water droplets and the light coming through them. It splits it into the color spectrum, but it's all based on angles. And it's really, really crazy. You remember Roy G. Biv, hopefully. Red, orange, yellow, green, blue, indigo, violet. And you see the rainbow in the picture here going from red to orange to yellow, to green to blue, to indigo to violet. You don't really see the indigo or the blue. One of them you could, pretend that you see. It pretty much just goes bluish purple. The thing I like to remind you about, though, is when we saw this in a color spectrum, it is the opposite direction in the color spectrum from what you might think about. And all I can assume is my usual bad joke is that Vib Gayor, just didn't sound like a name. And Roy G. Biv kind of does, so that's why they said it that way. So, to ruin rainbows for you, here we go. So the light from the sun passes through a raindrop, and it does that every moment, every day. Whether you're standing there staring at it or not, it's doing that. Okay, the rainbow's there whether you observe it or not. Although the guy whose video I'm going to show you might disagree with me. So you've got a mixture of refraction and then reflection. Okay. Refraction is twisting it, and I'm sorry, refraction is splitting it up, and then it gets twisted as it gets reflected back to the other side of the, I almost said light bulb, of the water drop there, and you see the lovely rainbow. Couple of things for this to happen. You've got to have the sun at your back. All right. In order to see a rainbow, you absolutely positively have to have the sun at your back. And it's got to be showing on some area where the atmosphere is still very moist. And what we've got here are just the two ends of the spectrum. You've got red at the top, blue at the bottom. So that red arc would literally be across the whole sky, so to speak. And the violet arc across the whole bottom of the sky, and then you'd have your filler colors in between. I'm guessing they thought it would be too much, to have all the colors represented here. But the idea is see how the violet is lower down in your eye there, okay? That's a different angle of, I'll say inference because that doesn't mean anything. You've got red at 42, you've got violet at 40. It's a different angle of vision, we'll just call it, all right? Within those 2 degrees, all the other colors are going to populate. So that's why it's dependent on your height, your distance, your everything. And that's why they technically say, now it's going to look the damn same, okay? Don't get me wrong. You could take a picture of the rainbow, you could take a picture of the rainbow, and it's going to look like a rainbow. But technically speaking, it's not the same one because it's really just a picture in your head of sunlight on water droplets in the sky. Nothing worth arguing over, especially with like your grandma or something. But it is technically true because that 40 inches or 42 inches, and it's the same reason you can never find the end of it either. You keep traveling wherever you go and a thing just moves on you as long as you have watery skies and the sun at your back. Utica's been ripe for them lately. Last year, it was last year, I caught a double one, which is really hard to do. I got a nice picture. I got to try and find it, show you guys again. Very, very cool.
I always see them when I'm driving.
Yeah,
Yeah.
which is the worst time to take pictures, but we sure try, don't we? I'm going to be extra, extra good. Or are you good and you don't dare take a picture while you're driving? Yeah, you're not going to answer that one on tape. All right. Nobody at home knows who you are. But no, that's where I have my wife take the picture, of course. But yeah, that's, I don't know, you're seeing more land or whatever, but ideally, yes, please pull over to the side of the road before you attempt to take pictures. I see a lot of clouds that way too, and I think it's just because we're jettisoning around the surface more than when we're in our backyard. But yeah, you do tend to see this cool stuff more frequently when you're driving. Yeah, I thought there was another refraction in there because it twists it back. That diagram just didn't have it though. Here's a double. This isn't my picture of a double, but that's what I meant by a double. So refraction, reflection, and then refraction through a water droplet comes in one side and bounces around and comes back out. I don't know why I have bounces around in quotes there, but cue Kermit the Frog and his banjo. All right, now as I said, I want to show you a quick video. You folks at home, please watch this video. I'm going to pause our recording. Well, actually, I'm going to stop our recording. But do watch these videos.